Okay, today we are going to create a database. Um, let's see, I just make. Um, okay, so today we are going to create a database. The database that has two tables. As you can see, one table is called a student, and another table is called a professor. So as you can see, we have a student table. So database, and then we have another table called professor. So this is a database, right? The whole thing is a database. And let's look at the column or the attribute. So we have a student ID column, the attribute, the name and department and professor ID. This ID of, for example, the student ID, right? This the value is always started with S. S stands for the student, right? And and then this is S. We have another student, and his ID is 200. His name is Kevin, and department is ACC, means accounting. And the Kevin's advisor's ID is professor ID is P200. So P stands for the professor P, right? Now let's look at the professor table. And it has a two attribute. This is professor ID, and the P100. The name of the professor is June. And let's look at another professor. His ID is professor 200, and his name is J, and etc. Right? So obviously, right? If you look at this two table, and you guys can immediately see that these two tables are related, right? These two tables are related. And so before we find a relationship between two tables, right? Let's just first find the primary key for each table. So for example, for the student table, right? The primary key is student ID, is obvious, right? Because this is a primary key. Because this primary key is unique, right? Through this primary key, we can uniquely identify each row, right? Each row. And then look at the professor table. So through the professor table, the professor ID is obviously the best candidate, right, for the primary key. So this is primary key for the professor ID, right? And you know that these two tables are related, right? And you know that we learned that the tables are related through the something called foreign key. To find the foreign key, we have to first a common attribute, a common field between these two tables. We know that the professor ID, right, and the professor ID is a common field. So we can immediately know that the professor ID is the foreign key, right? So this is a foreign key. So as you can see, by definition of the foreign key, this foreign key is used in another related table, right? And listed as a professor ID. For example, P100, right? Is used in another related table as what? A primary ID, right? And let's say P200 is also listed as a primary key in another related table. 200, yes, we have 200. 100, yes, 300 here, the 400 here, right? So basically all the values is in the foreign key. We can find that value in the primary key field, like the professor ID field in the professor table. So that means the referential integrity is satisfied, right? It's properly enforced. And another thing that we can find out from this two table is that the professor P100, right? This professor has 2 students, right? So S100 and then S300. So the L and Kate, right? So this Professor P100, based on this table, advised 2 students, S100 and S300. So Professor P100 advises L and Kate. So this is like I mean, we have so this is like a one-to-many relationship. So the symbol, right, for that is 100, right, and also 300. I mean, for the 300. So this is like a one. So by looking at this, we can say this is 1, 1, 2. So by the way, this is a symbol for the one-to-many relationship. Okay, so that means one professor, right, advises 2 or more students, like 1 to many. So this is 1. So basically, this is like one-to-many relationship, right? So it forms. This is the symbol for many. So this is like forms one-to-many relationship. Okay, so I'm going to start. Oh, actually, next lecture will show you how to implement these 2 tables using Microsoft Access. Okay, so I'm going to stop recording my lecture here. Let's see. Okay, so let me just stop.